you can get that by going to the tools options. And if you go to the tools options, then here you can define like the size of the font here. So it can be console 16, whatever. So you can make it bigger if you want. And I made it a bit bigger to be so that it's visible inside the video. And also you can turn this navigation part here and also turn on or off these white spaces, which is helpful. If someone is familiar with Python coding, that's something that also is there, and it's more important there, this indentation, but it also helps reading the code much easier here inside Grasshopper C#. So you also can basically debug a line of code. So if you have like a line of code like int I equals like 0, and then for example you're saying that for you make a block of 4, let's make this k, and then I would say k plus equals I, and then I would say console dot write line k. For example, if I want to check this line of code for whatever reason, to make sure that it works correctly, I can click on this red dot on the side, and then here, if I click run, you would see that what is the error of my code? Oh, if I here I have a problem. I less than 10. Okay. Yeah. I'm actually not used to using these templates yet. So every time I use a template, I do something wrong, because I did it now to make the whole class faster, but I'm not used to it. So you see, when I click run, it stops here and it tells me all the information here. So it tells me like what are the values, how much is what value, and then so we have I here, which is 0. We have some other variables here. We see some of them are null, and then we have k here, which is 0. So you can check all the variables inside the terminal and see, okay, what's going on? What is correct? What is not correct? You can go to the watch, so you can write watches, breakpoint, problems, terminal, and see everything. So if I basically go here, you see the tooltips. That's a continue debugging, or step over next instruction, or step into function method call, and step out of the current scope. That is why that happens, because sometimes you have a function and you want to skip a function. Sometimes you want to go line by line and check each line of the function. So if I click here and say step over next instruction, it goes there and it again stays there. And I see I is still 0, k is still 0. Okay, because k was 0 and k plus I is 0 still. Then I go next line, then the for loop goes. Then now this time I is 1, and then you see k is 1, and then I continue, and then you see again I becomes 2, and after that, basically when we go one more line, k becomes 3 because it's 2 plus 1, 3. And if I continue like that, every time it stops only on the k line. Okay, so this debugging is also very helpful and important. And sometimes you have errors that you have to debug a line of code to see why something is wrong. Okay, and if you click here again, it is disappearing, and then you can continue writing the code in a normal way. So you get only the output. This was one thing I wanted to explain before continuing. Then I wanted to complete something about methods and functions, explain something to finish everything about methods, because I think it was very fast last time. Sure. Here. Mm-hmm. Mm-hmm. Yes. This means this is again the operator. So the point is this means let's do something interesting. Go to go to ChatGPT now and ask your question from ChatGPT and see what does it answer. Because this is what I explained last time, okay? But you forgot it. The point is like if this question comes to you again next time, you need to be able to resolve it on your own so that you can proceed, okay? Mm-hmm. Exactly. Yeah. So it's like k equals k plus 1, k plus I. So what does that mean? It means that every time whatever is k will be added to I. So the first time it's 0 and 0. The second time it's 0 and 1. It becomes 1. The third time it's 1 and 2. It becomes 3. The fourth time it's 3 and 3. It becomes 6 and then continues. Okay. So these are the assignment expressions and incrementation expressions. So plus plus always adds 1, but plus equals always adds the right side of the equation to the left side of the equation. Okay. So if we have a plus equals b, it means that whatever a is, it will be added to b. B would be added to that. If it's minus, b would be subtracted from that. If it is slash, if it is division, b would be divided by that. That's like something that we can have with many of the operators. Okay, so then defining methods and parameters. We defined different sorts of methods, but we talked about different sorts of methods, but I think we only defined one type, which was a void, right? So the question is that how do we define methods and what do we do that? So if you're inside Grasshopper, there is something about Grasshopper you should know about the syntax of Grasshopper. So I show it basically here because that's easier. I already prepared it. Okay, Grasshopper integration. So what's happening inside Grasshopper is that inside Grasshopper, we have a using part, which we define the references. Then we have a public class script instance, which derives from Grasshopper script instance interface. And then inside that class, which now we know what is a class, inside that class, we have a private void run script, which has some inputs and outputs, which you already played around and you learned how to use them. The ones which are input are by value types. They get the value and they come here. And as soon as they arrive into the Grasshopper, they belong to the Grasshopper run script component, run script function. Then we have reference types, which are object A, blah, blah, blah. If we add to that whatever, these are the outputs that we have. So if I write here A equals something, then it means that I'm pointing out the memory address of something to A. That means that in the output inside Grasshopper, other components of Grasshopper would see the value of that memory location. And the Grasshopper keeps that memory location for me and reveals it to the outside world, the world outside this Grasshopper instance. Okay, so this is how we basically produce output inside Grasshopper. Okay, then the question is if you want to like write a lot of code inside this run script, that could get like super big, overwhelming, and debugging of it can be really difficult. So that's one of the reasons we are defining those methods. But the question is, where do we define the methods? And if you're defining classes like point 3D or whatever that we talked about yesterday, where do we define those classes? So you can define the methods only in this area. What is this area? It's outside the run script and it's inside the class script instance. So you always can only define methods inside a class. You cannot define methods somewhere on the air, somewhere random in a hollow space. The methods or functions should always belong to somewhere, and that somewhere is a class. Okay, so what we should do here is that what we can do here is that if we want to define a method, for example, define a method that is called, like, I don't know, it's a method that does something for us, like prints something for us. We can write that method inside this area between this curly brace, which is like the end of the private void, and this curly brace, which is the end of the public class. Okay. Then there are sometimes that we want to define classes, and that class might have methods, or one method, or several methods and functions, or properties, or whatever. Where do we define that? That class you can define also here. So it would become a subclass of a class. So when we define classes, that's not the end of the world. Every class can have several classes underneath, and that class can have several classes also. So why do we do that? Because, for example, maybe you have a class which is a script instance, okay? But then you want to define a class for your script instance, which is only readable for a script instance. And you can only use it, not anyone outside this script instance, okay? So you define it here. Sometimes in a bigger program, you want to define a class which can be used for several components. For example, imagine you're developing a component, developing a plugin. For example, you're developing, let's say, Karamba. Then you define a class which calculates some forces. You define that class outside the script instance. Of course, that is inside Visual Studio, but you define that class public for your whole program. So basically what happens is that all of your components can make an instance of that class and can use the methods of that class and can work with that class. But if you have a class which you need enclosed and only controlled by one component, you can define it here in this area. But if you want to define a class publicly, you define it here outside the public class. Mm-hmm. It is, yes. Um, what probably what is in your mind is correct, but the way you said it can be wrong. So let's elaborate a bit. What I guess what is in your mind is that I can customize the script instance class of David Rodden. That is correct. Okay. Locally, of course, but when we do that, it doesn't mean that you need to define it private. It's still for you a public class, okay? But you can override the methods and everything that this script instance has. Actually, we are doing it right now with this one, with this private void run script. We are defining our own run script. We can do that with other voids of the script instance. So, for example, you can go to Explorer and search for GH script instance and see what are the methods and everything there. And you can define all of them here, and you can work with them, and then you can change them or overwrite them or do something about them, okay? And this is actually what we a lot of times do. So, for example, when you see there is a grasshopper component which looks not similar to the grasshopper components which are the normal components of Rhino, and they have different interfaces. Those people basically override the interface, the shape of the form of the grasshopper component that David Rotten has, and then they produced a different shape. So, for example, there was this component structural plugin called, if I'm right, Millipede. something like that. Like it looks something else. It looks super graphical and fancy. It's also slow, but yeah, this is something that you can do. So you can change everything. You can use the foundations that they made, use the libraries and everything, but change everything also the same way. You can also, for example, like write your own point 3D and overwrite the point 3D which is there. Write your own point 3D, change everything, and then make it behave differently. This is also possible. Okay. Here in a Grasshopper script, you have some limitations, but when it comes to Visual Studio, when you go to the programming space, you can do everything, almost everything. Okay, so this is important to know. So for example, if I want to do something in an example that we're gonna go later, for example, that we're gonna work with later, I'm going to define a function which I call geometry bend or geobend. So that function does something for me. So when I'm writing the code, I only write geobend something here. I send the parameters to that geobend, and then I'm done. So the run script is a very simple code. But here, I'm defining the geobend function. And then every time I want to check something, I'm checking it inside geobend. And also, I always try to keep all of these methods and functions as concise as possible. Why? Because when you make functions super big, it's difficult to resolve the problems and debug them. So, for example, if I'm doing one specific operations, for me, I have a criteria. If I do something more than 3 times, or 3 times, I definitely define a function for that. So, for example, if I have to define the area of a triangle in a specific way for a specific situation that the normal area of components inside, like Rhino, they don't help me, or I have to do several things to get out of that, I go there, I define my own function of try area, like my try area or whatever, and then every time I want to get the area, I just write try area. I input the 3 points of the triangle, and I get the answer. So I'm not writing, for example, those 3-4 lines of code, which is getting the triangle for me every time. I write it once, and then every time I just call the function to calculate the values for me. Okay. So for example, let's say I want to every time put inside a variable something that tells me what happens. Okay, so for example, when I'm debugging my code, sometimes I may debug inside Grasshopper, and I may get the information here in the terminal. Okay, but maybe when I'm writing the code, I need to always know what is the value of something. Okay, so I can, for example, here go to the run script part. So this is the run script. So I go out and I go between the pink and the yellow one. It means like inside the class space. Okay. So I'm writing on the same level of this code, not inside this scope. Okay. This code belongs to the class scope, and I'm writing inside the class scope, not inside the scope of the run script. Okay. Now that we know what does scope mean, we can talk like that. We can talk professionally. So for example, I can define here string. For example, info A equals 0 equals nothing, and string info B, for example, equals nothing also. Okay. And then imagine, this is actually something that I had back then. I show you. So for example, I had a function which was called info for myself. I made it myself because I didn't have access to console.write line in the previous versions of Rhino Grasshopper, and I had to print to get something. Okay, so what I was doing was I had this like function here, like public info with an input, and the input was what? Was int a. Okay, and then close braces. What is the error? Public void info. Why? Because it's only doing something. And then inside here, I was writing print, because back then we only had the print a dot to string, and then close. Okay. Okay, so this was one function. Then I knew that there are some times that I want to print double, but I don't want to like again put the dot string. So basically with this function, what I get, forget this one for now. I'm gonna talk about it later. So this is a method that I defined. Okay, so here instead of console.writeLine k, I could say info parentheses k. Done. Okay, so if I run the function, if I run the whole code, I get this. Okay, now the question is that if my k was double, okay, here you see, I would get an error here because it says info receives int. It doesn't receive double. And if I was printing, I always had to say print a.toString, k.toString again. Okay, so here I can make an overload of info. So I can say info again. I can say, I can copy this line, this piece of code, write it here again the same way. This time I would say double a, and again a.toString. So info understands that it has two overloads. So if I say info parentheses, it shows me two overloads. It gets an int32 and it gets a double at the same time. Okay, so it doesn't matter what it is. It does it for me. Or I may want to show different values at the same time. So I could have int a, comma, int b at the same time and say, here, if there are two values, just print what? Please print dollar this, and then value a is, and value b is, then value a is a.toString, and value b. Can you mute? Yeah, sorry. And value b is this one. So every time I want to print two values, instead of like doing everything like that, I can just say, this gives an error because this is gone. I can just say int k, comma, I, for example. Okay, k is double, so I should say int. So int ki, and if I run that, you see that it does it for me very easily. So in this way, I can have several different overloads of info based on all the ways that I want to print information. And every time I want to get information, instead of, for example, like imagine there are several times that I need this sort of two values. Instead of writing this whole line of code, I'm just writing info ki, info k, info I, and I don't think about it. So this is something that now with console.writeLine you can do. But again, you might think that, hey, this console.writeLine is too much for me. I just want to avoid this console.writeLine. And I want to have something that I understand and it's easy, and I'm avoiding like console.writeLine. This is too much. I just want to say, okay, I don't know, I, whatever, something that I understand. I don't care about the rest of the people in the world. I just want to, this is for my debugging, so I just want to have it. So it's I, it's fast to write, and I can get information very quickly. So these are, we defined three different overloads of a void method here. We could do the same thing with other methods. So for example, we could have a public mySum, and this time I define it as integer. Public int mySum int a, comma, int b, And then I close this, and here I would say, what does it say? It doesn't have a value. So, and I can say return A plus B. Okay, so it adds two values. I could say, the way that I'm doing it now is stupid. We don't do it like that in professional programming, but I'm just like, I just want to make examples, okay? I could say, okay, there is int A, int B, int C as well. And I want to have also int A, int B, int C, and int D, for example. So I would say A plus B plus C plus D. And then here, we don't have D there, plus C. And here I would say plus C plus D. Okay, so every time I want to show something, I want to do something, I can say actually here int I. So I would say I. So for example, I run my function like my sum k comma I. So it adds k 2 times with I. And when I print, I would see these values. Is it clear? Yes? Okay. So, what do you mean? I didn't get your question. Mm-hmm. Mm-hmm. We use this one. Here, I said my sum, KII. Yeah, I used it inside here because this my sum returns a value. And to return a value, you use return. So I could do several things. So I could, for example, here inside A plus B, imagine that, for example, this my sum was like something that should do something. Actually, it's not a summary, but it is doing something that we don't know to A and B. Okay, so for that, what happens? So it's like, for example, it's defining int sum equals to 0. Then it says like sum equals to A plus 500. And then like, or that's A plus 500 multiplies to B plus B, for example, plus, what do I say? This time A multiplies to B, for example. Maybe this is a formula that we want. And this time we want to return sum. So if someone uses this overload, it would get a weird value like that. So here, if I go back up there, if I run KII with 3 inputs, it runs this one with 3 inputs. So basically what happens here is that the K would be assigned to A, so it goes here. The I would be assigned to B, it goes here. And again, I would be assigned to here, so it goes here, okay? And then if I use the one with 2 inputs, so instead of that, then it would use this overload with 2 inputs. So if I run it, you would see I get these weird values. Okay, so there might be a situation that actually I want to receive 2 integer values, sum them, and then return a double value. So can I, this is a question that you need to understand. Can I say public double my sum, parenthesis, int a comma int b. No, it's impossible. Why? Because when you have a function with the same name with different overloads, the exit of the function should be always the same, this return value. You cannot have different sorts of exit values because this destroys the whole compilation of the program. You can only change the inputs because you can have control on inputs. But if the outputs are different, then the compiler doesn't understand, okay, now should I give an error or should I not give an error? What happens here? Okay, so if you define different overloads, those overloads should always have the same type. Okay, then, so what if I have a function that might return different things for whatever reason? Or what if I want to have a function that returns two things? Because this function only returns one thing. So, for example, what if I have a function that returns the toolpath for a 3mm bit and a toolpath for a 6mm bit, or a toolpath for the 3D print and a toolpath for milling, for example. So imagine that you have a function that returns two values. You send one value to the 3D printer and one value to the milling machine. And then you get two things and then you patch them together and it works. How can I do that? This is also possible. So let's define a different function. I clean up here so it's like easier to understand. So to be able to return more than one value, you can have a function which is either a void function or a function with a type. We already used one of them, like myParse, try parse, if you remember. But we're going to define something like that now. So how do we define that? Imagine that I want a function. Imagine that I want a function that adds two values and returns both an integer output of those two values and a double output of those two values. Okay, how can we do that? We're gonna say public void var sum, like variational sum, let's say. Okay, then we would say int a, int b, comma. Then here we can define the outputs. Similar to here, similar to the rhino, here we again use ref because this would be a by reference type. Ref, then alt a, but what type? An int type. Ref int alt a, comma, or let's call it alt int, so it's more understandable. And then ref double alt dbl for double. Okay, now what do I do? I can say, okay, alt int equals what? Alt a is integer, so it can be easily a plus b, done. And I would say alt double equals, no, I don't need the alt, I need the name, I was confused, like alt dbl equals what? Now I need to cast, because if I say a plus b here, this doesn't work. I'm gonna have an error. Why? Because alt dbl is a double type and a and b are integer values. So I need to cast them. How do I cast them? I can say make a double cast for the result of a plus b. Okay, so it sums them together and then makes them double. So now here, what I want to do is that I want to basically console dot write line, console.writeLine. What? We want to run this function. To run this function, actually, we don't want to write it here. We don't need this for anymore. So here, we need to run this function. To run this function, I can say var sum, and I open the parentheses. I get 4 values. I can say 5, comma, 6, comma. Here, because it's a reference type, I need to introduce a variable because a variable has a memory location. So I need to give it a variable that I can use later. So to be able to finish this method, I need to have variables before. So what can I do? I can say int out int equals 0, and then double dbl int equals 0, and then here, when I'm going back to the var sum, I would say ref. So by reference, give to it out int, comma, by reference. This I wanted to make by reference. What is this name? I'm like super tired. Out dbl. And then I close this. Okay. And now I can print one of them. Just let's run the code for now and see what happens. Nothing. We don't see anything, but the code runs. Okay. So if I use the console.writeLine, actually, let's make that function. That was helpful. Yeah. Hello. When did you join? I didn't realize. Okay, good. I'm gonna go through all of it once more because I just want to first write the code and then show you what happens. So I'm writing console.writeLine. Let's write out dbl. Okay. So if I run this code, I would get 11, right? As a double. If I write out int, I would get again 11 because the sum is the same. Okay. But what's happening here? Let me explain the code. So here in the var sum, I define int a. This is a variable which is an input variable. I can use this input variable inside my method. Then I define int b. I can again use this input variable inside my method. Do whatever I want with it. But I want from this method to have 2 outputs. Now we are using a banal output, whatever. But imagine that we're gonna have different outputs, which we're gonna use later later today. So to define outputs for such a method, we can have reference outputs. So why do we use this ref value? When I write this ref keyword before the int out int, I'm telling the compiler that, hey, whatever you receive from the user when they are using this method, when they give you a variable, I don't care about the value of that variable. I need the memory address of that variable. So then here, inside this code, we run var sum 5, 6. For int a, it gets the value of 5 and sends 5 to our method. So we know here that a is 5. We do whatever with 5. then it gets the value of 6 and it sends it to here. So we know it is 6. That's why actually we can enter here something as a value, either the value itself, or we could have, for example, like int a equals 5, and then here instead of 5 I write 8. So this works, right? Then when I send a to here, because there is no ref here, the function doesn't care about the address of a. It just takes the value of a and sends it, and it forgets about the memory. So we don't care. We just want the value. But when I come here to the ref int out int has a value, but I would never get the value of out int here. I mean, I get it because I know where inside the memory it exists. I can have the value if I want, but I don't care about that. What do I care about? So, for example, here, we should be able to basically say console dot write line out int. Okay, so if I run the code, I would see there is a 0 here. So we know the value, but we actually don't care about the value. We can use it if we need. We can use the initial value, but that is not a common thing. That happens, but that is not common. But we don't care about the value. What we care about is the memory address, because now with ref we know the memory address, some memory address here inside the scope of run script that belongs to this out int. Why did I use the same names? Can I use different names here, or am I obliged to use this name? Do you have any opinion? No opinion? So, no, I could. What is your? Yeah, it could be. I can define this as Afshin, but and then this could also be Afshin, and then everything is fine. Okay? It works still the same way. The question, and then another question. Didn't I say we could only define one variable name once in a scope? Why didn't I get any error? Because I have out int here, and I have out int here, and I have out int here. Why there is no error? What is that place called? No, because I want the correct description. You are right. You know what does that mean, but you need to be able to explain it properly, because then you avoid any mistakes. Because it is defined they are defined in a different scope. Okay, so exactly, yeah. So this out int is defined here in this scope. Okay, between this one and this one, and this out int is defined inside this scope. And this scope never sees this scope. So actually, yeah, exactly. So if I basically were defining this, if I was defining, for example, a variable called public out int, public int out int equals to 0 here, then this would give me an error if I run the code, because these out ints would yeah, exactly, that's the point. So this is something that you have to consider. But this is I usually use the same names because it is for the clarity of the code. It helps me understand the code much easier, and I always know what I'm doing. So it's a common thing to use the same names. And then also, to avoid some mistakes, you can have specific conventions. But for example, when I'm going inside the scopes, I might add underscore or something like that to my variable names. So I know that if a variable name is with one underscore, it's once inside the scope. If there are two underscores, it's two levels inside. And if there is no underscore, it's the bigger level. So when I want to debug and I see the variable name, I already know, okay, this is that variable which was there with that problem. So I can easier debug the whole code. But this is something that you will see for yourself. You will get to there on your own. So here I said yes. What do you mean if I delete? So this one. So first of all, let's say 65. You deleted these two. Okay. When you delete them, it's ref int what? It's a definition. A definition needs a name. A child a child needs a name. Then we don't have any output. Okay. Okay. The script works, but it doesn't do anything for us. Where should you write the print? You want to write this console.writeLine here, inside here. No, there is no out int. Where is the out int? Here, but there is an error because there is no out int declared here. I actually should remove there. So where do I put this a plus b? What do I do with it? So what do you do? It's like a plus b. Where do I pour it? It's two values. I need to pour it to a container. Okay, where do I pour it? No, I'm asking what is your opinion? So the point is like you want to get rid of that out int, okay? Uh, the point is this function doesn't know the outer world. It's a function within its own world, okay? So it needs to find a communication way to the outer world, to the bigger world, okay? What is that communication way? Return values or reference values. So int k equals this k a plus b. Okay. And then what? So you want to write up there k. So you want to okay, so you want to basically define public int k here, right? No, this doesn't work because this k only belongs to here, and we don't know k here. Who is k? Hmm? It's not a variable. It's a method. It's a public method. We can see it there, but int k is inside var sum, so we don't see that. It is integer k. Here you mean. So What would we write? We write int k. Okay. Okay. So the question is that now you say that you write integer k and then you say k equals a plus b, right? Okay. So it was a nice question. It's gonna help us. It's gonna help you understand it better. So here you would say, okay, I have a int k, and then here I would say comma, and then I write, for example, I write this out int that I defined here. I write it here, right? So you think this out int would go to k, right? Because the out int go here, and then I say k equals a plus b. So after this line, my out int should be basically 5 and 6, 11, right? Is that what you think? I didn't get your question. So no, first let's don't broaden the question. Let's first fix this here. So here you thought that you think at this moment that if I have this, like, if let's define this k so it's not confusing you, okay? So if I send k here into this like var sum, and because I said here k equals a plus b, then k should contain the sum of a and b. Is it what you think? Why doesn't it make sense? Mm-hmm. But we have three inputs here. Exactly. Exactly. Yeah, that's the point. That's the point. If you just write int k, that's considered input. So the point is, if I write var sum parenthesis a comma b, 6 is b here, okay? It doesn't matter it is 6 or what. 6 is b because I'm sending 6 to b, okay? So basically, let me turn on the annotation so I can do that. So a is basically this one, okay? And it is 5, right? 6 is b. And then whatever we write here, whether it is k, whether it is kesra, whatever it is, this is this one, okay? So the point is, when I run this function, it checks a. It says, okay, there is a value of 5 inside a. Send it here. So when I start this, I know that a is 5. This is what the function knows. Then it knows b is 6, right? And then it knows k is 0 when the function starts, okay? And then it says, okay, now k equals 5 plus 6. So after this line of code runs, k would become 11, okay? So now k is 11, okay? But what's happening here is that this k is not this k. Why? Because if I draw the memory of the computer, the memory is divided into two parts, okay? So we have on one part these variables. So this part is the upper part, is this one. And then here is here, okay? So on this part, we have three memory cells. So the first memory cell belongs to A, okay? Then and it has 5, okay, inside of it. So when we run the function, it takes this 5, makes a new memory cell inside here, and puts 5 in it, and calls it whatever. Here, it calls it A. So this A is not that A. This is a Kesra in Adana. This is a Kesra in Vienna. These are two different Kesras. They're not that they only have the same name, but these are two different people. Okay. Then you have 6. 6 is an on the air value. It doesn't have a memory space. So we don't have a memory space. It's just sent here. There's another memory space called B, and this is filled with 6. Then this function makes another memory space, the third memory space. The third memory space is for K. Here we also have a K memory space, and it has 0. Okay, then this K goes to this memory space first. Okay, and it becomes 0. So where are we now? We are on the first line of the code here. Then the second line of the code, line 68, is running. What happens here in line 68? Now after line 68, the memories would become 5 is still 5, B is still 6, K would become 11. Then what happens? Then this line of code, line 72, the whole thing terminates and these are done. The computer deletes this memory, comes back here. So we again have these values, and if we print K, here we get this K and we print 0. Okay, so let's run this code. Do you see what's happening here? Okay, so if I run this code, I have 0. Okay, so if you want, take a screenshot of this. It will be on the video, but take a screenshot because I'm going to delete the screen now, and I want to show you the second analogy. Okay, so this time, what happens? Let me turn on my pen so I can draw a bit nicer for you. This was with mouse, it was like so bad. So give me a second. Okay, it's not working. Let's do it. Here, now, instead of doing what we did, we are going to just add one keyword. And that one keyword is ref here. Okay, is ref here and is ref here. Okay, so we just added one keyword. Now let's see what's the difference. Okay, so what we have here this time is, let's go to annotate and draw. Okay, so this time I have again let's divide the space. So we have a bigger space. This is the space of this scope, and this is the space of the function. Okay. Now in these two spaces, we have one memory cell for A, and we have one memory cell for K. Okay. So what happens here is here we have a memory cell for A, and this memory cell has the value of 5, right? Then we have a memory cell for K, and this has a value of 0. Okay. Then we run the var sum function. So what happens in var sum function? We run this var sum function. It goes here and it says, hey, someone called you. So what is A? It's A. It refers to a memory with a value of 5. Okay, make a memory cell for me, and then call it A, and then put 5 in it. Okay, what's the second? Okay, it gives you value of 6. Okay, make a memory cell, call it B, and put value of 6 in it. Okay, what is the third one? It's a reference one, and it is referred to a memory which is called. Okay, what is the address of that memory? For example, let's say this memory address is 1100, something, whatever. So this 110, this one will be sent here. Okay, so basically this variable makes a K, but it doesn't allocate a memory. This K would be referred to here, to this memory cell, because there is a reference key before that. So it gets the reference of K. It doesn't occupy. It just understands it. It doesn't occupy anything. It has it. It says, okay, I can access that. It gets access to that memory space. It's not doing anything to it. The memory space is there. Now we can also use it. Okay? It's like whoever is there is there. Okay? Yeah. No, it doesn't have 11 yet. At this moment, if I print it here, it still has a 0 value. It's not yet 11. So it's not occupied yet. Okay? We have access to it. It's a room. I can go, I have the key, and you have the key. Okay? So here it says, okay, K is now A plus B. So what is A? A is 5, B is 6. So I have the sum of 11. Where should I put it? Put it to K. Where is K? Here. So it goes here, and now it occupies it, and it puts 11 inside. Okay, at this moment. Then this is end. This is done. And it says, okay, we are done. You say goodbye to here. We clean up all the memory here. Okay, perfect. We go back. Yeah, and now it says print K. It says, okay, where is K? This memory space. What is in there? It's 11. Okay, print 11. If I now print this whole thing, this time, it would be 11. Yes, if it's here, yes, it's 0 11. Yeah, and if it's also here, this would be also 0. Yeah, because it is still 0. That's what I said. It's not occupied yet. Yeah. No, you got it right. The point is like here, we refer to a memory space, okay? So at this moment, we still didn't do anything to that memory space. We are taking the value of that memory space. So here in this console.writeLine K, it goes to memory space and it says, okay, what is in there? Is there something in there? And the computer says, yes, there is a 0 sitting here. It's like, okay, give it to me. Someone wants it. We take it and we print it. Then here, we say, okay, there is a sum operation, add it. So this line is anyway after that line. So it's not about order operation. This line is still not there. Okay. No, the order is 53. Then it jumps here, 68. Then it is 69. Then after 69, it goes here and it is 56. Exactly. Yeah. 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 I didn't hear it completely. I thought you skipped this line. Ah. No. Yeah. Yeah. Okay. So is it now clear, this whole referencing? Okay, so the point is why, one naughty person might say, okay, why I don't define some public variables here, and then I assign those public variables here, and then I use it here. I thought you are going to say that before. You were thinking about it. That I think you were thinking, you mentioned something that I can define a public int k equals 0 here, okay, and then don't define k here at all, and then send k to this guy, and then here, and I don't define this here even, and then print k. Yes, this is what you were trying to say. Do you think it works? It works, okay, but there is a big problem in that. You know what happens here when we define this? The problem here is about the memory. So we start the program before even going here and going here, okay? This time, this is something very important that you have to understand. This time, we actually have a bigger memory space up there. In this memory space, we have one part which is occupied by this run script thing. And we will have one part which is occupied with k. Okay, so this is k. And then we start the code inside here. Okay, so this part which is occupied by k, because we defined a k value, okay, would be forever occupied. So we run this, we put something in it, okay, and then we're gonna take it here inside the code. Then imagine that I'm using this var sum operation somewhere else in my code as well. What if those two methods at the same time are putting some different things here? Who goes first? So someone wrote this var sum somewhere here, and then the result is 11. Another method somewhere else returns like 12. And then that 12 goes immediately between the moment that I call this method. So after I call this method, there might be a few milliseconds before I print. So I ran this, the value is 11 because of me. Then someone else ran it while I was going to the second line. The value is 12 and I print 12. So the value is not 11 and it's 12. And I'm saying, hey, how is it possible? 5 and 6 are 11 and it's giving me 12. So first of all, this is called unsafe programming in a way. So your memory locations are not safe. And another problem of that is that now we have 1K. Imagine we have several classes and everything that each of them are taking, I don't know, maybe like 1000 kilobytes of memory or something like that. And we have 1000 variables. Then from the beginning of program to the end of program, all of this memory is occupied. So you run your program. Before program does anything for you, you suddenly see, okay, I had 32 gigabytes of RAM. Now I have 2 gigabytes of RAM. And this program consumed 30 gigabytes of RAM for doing nothing. And every time I do something, I don't have enough RAM. But if you have these safe values, you run the program. Your RAM was 32 gigabytes free. It is now still 32 gigabytes free. You run a process, it's maybe 30. After, it's again 32 after the operation is done. Why? Because for that operation, it needs some memory. And when that function is done, it clears the memory of that function, comes back here, and only occupies memory for this part. You see? So in this new terminology, which object-oriented programming gives us, we basically have this base memory. We have one part which is occupied for our class. Then we are going to have other parts like this part, which is occupied for the K, and then it's freed up again. Then again, another place occupied for I, and then it's freed up. Another part is occupied for something. So this part is floating and always free. But in that terminology, we would just occupy and occupy and occupy and occupy, and then we are done. We have to stop the computer and restart the computer. And believe me, there are some non-programmers who are writing programs in this terminology. We have plugins like that in Food for Rhino. Yeah, it is really important. It's really important. And it gets even more important now when you are using ChatGPT. Because the point is, you might use ChatGPT for chunks of code, but then you start to define the variables on your own. So it's not only on ChatGPT. It's like ChatGPT delivers you a gun. It doesn't ask, what are you going to do with this gun? Are you going to protect yourself, or are you going to murder a lot of people? It's just like giving you some guns, and then it's up to you how you're using those functions. How much of the memory are you going to kill with those functions? So you need to be really careful about this memory allocation. So I guess it was a very good understanding of. Now I think the biref bival is really clear for you at this moment. Okay. So, yep. Ah, nice. So I did not check my emails actually. Yeah, yeah. Hmm. Yes, I'll check it definitely. Okay. So we will check it today after our lessons. Okay. So we are done. We are done here. Let's go back to this part. So this is done. This is done. Let's go to lists and collections. Okay, so this is a very important topic in Grasshopper and in general in programming. So we have a type which comes from classes and upper hand types. We have types which are called enumerable types. What do we mean by enumerable? These are types that can be counted. And these countable types there are different types. There are countable types that they can have indexes, and there are, or indices, and there are countable types that they don't have indexes. Today, I'm not going to talk about those indexless types at this moment. I'm going to just talk about like index types. But what are they? So we have the classic global type, which is called arrays. And what are these arrays? So arrays are basically specific fixed size. This fixed size thing is really important to understand. So let me take it to view. It's a fixed size ordered collection of elements. What do we mean by fixed size? When we want to declare an array, which is a list of things, those things can be integers, can be strings, can be points, can be, I don't know, human beings, can be monitors, whatever which is declarable inside the C#. That list needs to have two specific information there. One, how many items are there in the list? And two, what is the typology of that list? Why? Because when we say what is the type of that list, we know, for example, that for each item, we need 2 bytes of memory, 4 bytes of memory, 8 bytes of memory, whatever value bytes of memory. And then with the count, we know, okay, now how many bytes of memory I need. So for example, if I say I'm declaring an int, which is basically, which is uh, uh, an array, which is an integer, and it is 3, it knows that, okay, I need to occupy 3 multiplied to the amount of memory that integer takes, and then I specifically occupy that amount of memory already for my future use. What does that mean? It means that I'm going to have like this amount of memory, 1, 2, 3, because the number is 3, for my array consecutively occupy. Okay, so and then I can say, okay, the first cell is 10, the second cell is 20, the third cell is 30. And then I can say, hey, that array that I defined, which was called number, give me the value of first cell, of the cell number 1, this value. And I say, okay, the output is 20. But what happens now if I want to change something? Can I say, okay, hey, I regretted that I defined a memory that has like an array that had like 3 items. Now I want 4 items. Can you make it 4 items? This is not possible. Why? Because when the memory was allocated, when the array was allocated in the memory, it started this array memory somewhere that might be that. Let me change the color so I make it clear. So before you declare that, there was another memory back there occupied for whatever thing. And after the declaration, the computer probably already immediately occupied it for something else. Now, if this is, for example, our memory in a linear way with whatever different things, now if it wants to change this, there is nothing here. And arrays, they don't link between the items. So if you want to continue this with the same array, here it is not possible for the array to say, hey, okay, this is my 4th element and make it 40, for example. This doesn't work. What should you do? You should say, hey, okay, there was this array. I had this. I want an array which is bigger. So just take these 3 pieces of memory, copy it somewhere. For me, at the end, somewhere available, make a new one with 4 elements, put 10, 20, 30, and 40, then delete these chunks of memory. I mean, this didn't exist anyway. So delete these chunks of memory, empty it, free it up. And then now I have this. So again, the memory was being used meanwhile. And then it was again occupied for whatever reason. And then suddenly when the memory is here, you again decide that, oh, I want to change again the dimensions of my array. This time I want an array which has like 6 items. So 1, 2, 3, whatever. Copy them like 10, 20, change one of them to 25, and then 30, 40, and 60, for example. And then again, delete and free up this memory part. So basically, actually, if we want to like correctly draw that, it would basically free up this memory part, okay? What happens? My memory is basically defragmented. So if I am after this point, this position, after this situation, if I'm making something which needs exactly that amount, the computer is gonna place it here. But if not, this place might stay empty for a while. So I'm basically not using my memory very properly. So what should we do? Are we doomed to such situation? Of course not. So there is another type of arrays or lists which we have, which we call them list of T. This is also derived from enumerable types in C#. Let me change this. There's a change of syntax. So if I write it C#, you see it colored. If not, you don't see it colored in the preview mode. So there is a list of T, and this list of T is defined as a list. And then how does this work? So this list of T consumes more memory. So for example, if an array with the type integer, with the type int, was using x bytes for each element of the array in memory, the list uses more than x, maybe 2x amount for each unit. But how does it work? The way that it works is that it doesn't use the same memory type and the memory system. So it has addresses which links the pieces of the array to each other. So the way it works is that we have the memory and something happens inside the memory. People are writing something. Suddenly we say, hey, we defined an array called a list called numbers, and we want to add one value as 10 to it. It says, okay, I'll give you a cell. I'll put 10 in it. And I go. Then again, we write some other places, something in the memory, and say, hey, again, you remember that numbers? It says, yes. I want to add another item. It says, okay, 20. Just remember, the memory address of these two are linked together. So let me draw it with a different color so it's clear that it's not that memory. It says, okay, just remember that this part and this part are referring to each other. So, and this is called item 1, item 0, and this is called item 1. Okay, then it says, okay, perfect. Now I want to add, again, 3 items. It says, okay, I add 3 items, whatever value they have, something. Just remember that each of them should link to each other. And it doesn't matter that they are next to each other. I still occupy this amount of information and I link them. So it's like wiring in breadboards, if you're familiar with electronics. And again, I have this cell here, and then I connect it to the next one, wherever it is. And then at one point, you want to remove one of these items. So, hey, you remember that second item? I don't want it anymore. Says, okay, don't worry. What I'm gonna do, I'm gonna make a new reference for you. That item is removed, but now I'm referring this one to this one. So this is a chain of elements connected with each other, but it can grow forever, or you can remove the elements. And you can always see how many elements you have and find an element and search through the elements. This is called list. Yes, but it doesn't matter for this type of class because it's in a different sort of memory. We have different types of memory. I don't want to confuse you with that. They have names, like we have stack memories, and we have different types of memory. I don't want to talk about that. Where lists are located, it is more versatile. Exactly. It is more versatile. So the question is that what are you doing? When should we use lists and when should we use arrays? A quick answer for you is that I think you probably have to use 99% of the times lists, and you shouldn't even think about arrays. Most probably, because of what you're doing. So most of the time, we have as architects or designers elements and items and entities which are constantly changing and are dynamic. They are not same entity. Okay, so for example, maybe a person who is doing machine learning or training, he says, okay, I'm gonna have a data set of 1 million items, and that's it. And I want to define that 1 million items. And I want to access between them very quickly. I cannot bear 1 millisecond slower for each access. So I have these 1 million elements next to each other, and I want to very quickly access through them. So I'm taking a big chunk of memory, put everything there, and I'm gonna use these information without changing them 10 million times for something. Of course, they probably need an array. Of course, they don't use arrays in machine learning. That's a different system. But I'm just like making an example which is kind of sensible. They might use, but from what I know, that's a different system. But whatever. So, but there is a case that's, hey, I have a surface. At this moment, I have 1,000 points of the surface or 1,000 subsurfaces of the surface. In 2 minutes, I might have 20 surfaces. After 2 minutes, I might have 2,000 surfaces. I don't know. It depends on my user, how they want to do something. This is a building. Now I'm going to remove windows, so you have more surfaces. Now I'm going to extrude. Now I'm going to have ornaments. Now I'm going to have something like blah, 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 whatever. So the situation changes constantly. So how should I do that? The point is you need to use lists because this is constantly changing. And you never know what element you delete and what element you keep. You don't want to constantly remove a whole thing and copy it somewhere and then use it. Also, imagine that you have an array of 1 million elements. Copying that 1 million, taking it, copying it somewhere else to make it 1,000,001 is a very big computational task. However, if you have 1 million and dropping something in the middle of those 1 million and then cutting those reference lines and say, hey, this point is between item 5,222 and 5,223. Now this element is 5,223. This thing in lists is so easy, but in arrays, I should say, hey, take an array, copy from item 0 to 5,222, make a chunk, copy it somewhere in the memory, take this one element, put it there, take the rest, put it there. You should move a lot of things. It's like moving buildings in the city. So you can imagine what happens to the memory there. So, mm-hmm, mm-hmm, mm-hmm. No, still lists. Still lists are better for that. Yeah, lists are faster. Plus, you have a lot of like search methods with lists that you don't have some of them with arrays. So still for that also for you also lists. So I say if you start like programming from now on every day in your life, probably and you focus on that and you constantly do that, probably if you're very active in that, you can get to a point that you really need arrays in a few months in a very optimistic way. Probably not in a year. So I should say, actually, I don't remember when was the last time I used an array in architecture or programming. I always use lists. I don't really remember. It's like probably it's years I've not used arrays for anything because I didn't need to even be concerned about that sort of efficiency. Yeah. Mm-hmm. 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 You want to add one integer to all 5,000 of them. So you want to change the values. I think probably there wouldn't be any difference.